Okay, so you can make, you can change things all you want. It's up to you. Okay. There it is. A couple of things here. If this project, there we go. So no problems here for the most part. You knew how to turn it into a decimal and percent. The odds, so a lot of you had the 250 here. So remember when you're going from probability to odds, right? You take the top number, but this should be 250 minus 3 because it is a crash compared to not crashing, right? So these two combine to 250. How many car crashes expected? So you take the probability times the number of drivers. So that's about 16 to 17 there. You just multiply it, you're making a prediction. And here I had a whole lot of different answers. But when you're going from odds to probability, you just add them up, right? You add these numbers to get your total. And in this case, it's in favor. So we grab the 17, right, of winning. State the odds against the Bombers winning. You just have to flip that. If you already have odds, don't be adding or subtracting or doing some kind of fancy stuff there. Just flip it, okay? The probability against the Bombers winning, you can look at it here, right? This is 13. You can look at it that way, or you can say if 17 wins, well, then it's 30 minus 17. There's 13 instances where you don't win, all right? This one was done well overall. I don't have many concerns here. I think this one, B, was worded differently, but what's the probability of not getting a blue one? So you take the total, subtract the 4 blues that you have. You don't have to reduce it, right? So if you kept it at 13 or 3 out of 18, 14 out of 18, you got the full marks there. In fact, don't reduce. Don't state it as a decimal unless I explicitly ask you to do so. I would just stick with a fraction. Red or gold, you've got two choices. You add them up, so it's 11 out of 18. Probability, I punched out the 2 here. So some of you use 75. Some of you use 275. It doesn't matter. You get the right. I didn't deduct anything there. Let's keep going. This is where a lot of you were confused. And, you know, sometimes it's a matter of checking your notes, but anything that is a chart that records what happened, that's what you're going to use for experimental. You can actually write that down. Okay, and the actual object that was used, whether it's a coin, dice, cards, what have you, this is the theoretical. That's where you take your theoretical probability from, which is actually the most accurate in the long run. So probability of the spinner landing on purple, there's only one purple section in theory out of 16 available spots, right? So it's 1 out of 16. Experimental, it landed on it 3 times, and if you add this up, it happened 30 times. 30 experiments were done. So it's 3 out of 30 experimental. Then the probability of a spinner landing on green, there are 3 green sections in this wheel. Out of 16, the experimental is back to out of 30, and it happened 9 times, right? So that's how you get the 9 out of 30. Theoretical of landing on yellow, same idea. 4 yellow sections here. It's hard to make these wheels, guys. So if you think it's the same one, pay attention on the test, right? Like it will be different. 4 out of 16. So I don't know if you notice the pattern. The theoretical should always be at a 16 here, and the experimental should always be at a 30. Because, right, we're always going back to this for the experimental. We're going back to this for the theoretical probability. Okay, and the odds. Odds of the spinner not landing on purple. So essentially it's not purple and then purple like that. Okay, so for theoretical, there's one purple section, right? How did I come up with the 15? There are 16 in total. I took away this one. That's how I came up with 15. So there's 1 purple and 15 non-purple sections. That's how odds are, that's how you have to think of odds. Experimental, 3 purple outcomes, and therefore out of the 30, that means that 27 will not be purple, right? When you look at the experimental, that table up there. And basically C and F are very much connected. Like if you did C first and then F, whatever you got here, you could just flip it the other way because this is in favor of purple. This is not purple, right? Against purple. So these are related. This one and this one they're related. All we do is flip though. We flip it. Because here, if it's odds in favor of purple, that means purple followed by not purple. Theoretical, you focus on this, right? On the actual object that was used, which is there's 1 purple section right here, therefore 15 that are not. And same with the experimental. There are 3 purple outcomes out of 30, which means 27 are not. Makes sense, right? And then we had probability of the spinner not landing on yellow. So what you could have done is gone 16 minus 4. That's 12 non-yellow sections out of 16. So probability, you're back to total 23 out of 30 for experimental. And then again, the probability of landing on blue, 3 out of 16 blues on the theoretical, 5 out of 30 in the experimental. So it was a bit repetitive, I get it, but I wanted you to think. What I could have done is flip this around, theoretical and experimental, but I thought it would be a nightmare to mark, right? If you don't catch that, it's going to be, some of you actually did it exactly reversed, every single one. I was generous there because I get it that you mixed up theoretical and experimental and then just kept going. I took off 2 marks once and that's it, because everything else lined up. You were doing it correctly, except for you missed the concept at the beginning. Let's go over to this one. I can guarantee you that you're going to have something like this on the test. So this is your outcome table, and you were supposed to tell me what the outcomes are, right? So 1 meets 1, so 1, 1 is what you roll here, 1, 2, 1, 3, and so forth. And what's up with all the highlighters there? Probability of rolling a sum of exactly 4. You want exactly 4, and if you remember, diagonal is where it's at. These combinations here give you a sum of exactly 4. You get 4, 4, 4. So there are 3 outcomes. 3 out of 24 total. How did I come up with 24, guys? I take how many options there are for the first event and the second event. 4 times 6. If they're both 6-sided, then it's 6 times 6. Right? If it's a coin, that'll be 2 options for a coin, and a die, that'd be 6. So 2 times 6, 12 outcomes possible, right? So you just multiply that. But you could have also just added this up and came up with 24 options. So 3 out of 24 is this. Probability of rolling doubles. Your doubles are right here. So there are 4 outcomes. Probability of rolling a sum of less than 6. So not 6, right? Less than 6. So it starts right here. This is 5. This gives you 5. So anything above that diagonal line, all of these options here give you a sum of less than 6. Okay, so there are 10 options here. This would be exactly 6. You do not want to include it. Then I would have had to read 6 or less. Okay? So you got to be careful there. 6, a lot of you missed the mark, and that's okay. But if you go back in my notes, right, we did like a order of a meal and drink. So I just kept it to 2. So it would just be 3 times 2. But if there are more things available, you just go ahead and multiply them all. It's like a password, right? If you have a 4-digit password, you would go 10 times 10 times 10 times 10 if it's just numbers you're allowed to use. So that's 120 different pizzas you're allowed to you're able to order. This one was done well overall. However, I will highlight the biggest part was that you forgot to add, like you're supposed to add both of these to come up with your denominator for that probability. Same thing here. You add these two to come up with a 96. When you go from odds to probability, you add, okay, to get your total. And students are more likely to being late, but not by much. You see that? I did that on purpose. Come on, staff. I just made those up, so I have no idea. And then the backside I added a little later. So mine is written. But the key here was that you eat it, right? Picks a white chocolate, eats it, state the probability of drawing a yellow one. So all 5 yellows are still left, but now I used to have 20. I'm down to 19 candies. So this is the probability of drawing a yellow. B resets. Now it says she picks a blue one, eats it. What's the probability of drawing another blue one? In this case, the blue and the total, both of those numbers are affected. So it's 6 over 19. That's why it's worth 2 marks. 6 over 19. A lot of you got this part, so I'm not too worried about it. And this was interesting to me. A lot of you said that the first one is independent and the second one is dependent. And I think why you said that is because, hey, look, there's a lot of it affected both numbers. The fact of the matter is, if anything changes, it's dependent. Like if the first event affects the second one at all, if you remove something, don't replace it. It's dependent, okay, guys? Remember that? Eating it, taking it away, not putting it back. If you make a group, if you take people out of the group, out of the big class to make groups, it's affecting the next probability of what's going to happen, okay, unless you put that person back or the card back or something. So depending, because the first event affects the total outcomes of the second event. And then the odds, I gave you a probability of 3 over 14, I believe. So the odds would be 3 and then 14 minus 3. So this would be 3 to 11 for that. So there you have it. That is your quiz corrected. I hope you took some notes. And maybe you just